Jake is actually originally, I should say his parents were originally from a state which is in southern part of India. That's where also it's from where I'm from as well. That's not the reason I've been asked to introduce him, though. Um, Jake is a co-founder and chief operating officer of Knockout Concepts. Knockout Concepts, after Ali, not about boxing, right? Okay. He was born in Philadelphia and moved to Loudonville, Ohio. And he's a graduate of the Boston University, and he's a medical doctor with a passion for medical entrepreneurship, with experience focused on startup companies. As you know, he started, this is his second one he started. He's experienced with product development, formation of advisory boards, general marketing, distribution plans, and the acquisition of capital investment rounds. My goodness, that's a lot of abilities. Jake spent 10 years working in government hospitals for the poor and indigent in multiple countries in Latin America. In addition to clinical experience, Jake has a strong background in developmental science, including multi-year research experience with biotechnology at the Ohio State University. He currently resides in Columbus, where Knockout Concepts is headquartered. Jake?
Okay, thank you. Thank you, CK, and thank you, President Tricia, and the entire club for having me here today. I really want to say one thing real first. Rotary is amazing, and I am very honored to be joining this club, if you'll have me. My whole life I've been around Rotary. My father, as CK mentioned, was a past district governor of District 660. He went on to become, youth exchange was his particular passion, and he went on to become the worldwide chairman of youth exchange for RI. And it was a position that the following RI president asked him to stay on, so he did actually 2 terms of that. And we had exchange students in my house my entire life, as far as back as I can remember. And so my father was a big believer in what Rotary does, which is bring people together in peace. And the idea of service above self is such an important one in this society, or in our world. And if we had a little more of that, we would probably have a little less of the horrible incidences like what happened over the weekend in Orlando. So I think this organization does actually work and do and affect change around the world, and I'm proud to be here to speak to you today. To jump right in here to what our topic and what I'm here to talk about, which is 3D scanning. Knockout Concepts is a startup. As Trent mentioned, we're happy and proud to be located in Franklinton, Ohio, literally a couple blocks from here. We are the first tech startup, I think, or tech company in Franklinton. And it's just an awesome place, and Trent and the entire Franklinton board are doing amazing work over there. And if you haven't been to Franklinton lately, I would highly advise you to go check it out. There's a lot of exciting things happening. But speaking on to Knockout, we are focused on mobile 3D scanning. And to give you, for those of you who don't know a little bit about what is 3D scanning, it's a technology that's been around for many years. And so, as we say here, man has long sought to capture reality. And 3D scanning has a long history, which starts way back, and of course with the computers, evolution to digital cameras, 3D graphics, and CAD software, which is computer-aided drafting or design software, were the real turning points there. And then you started in the early 80s, you got 3D scanning. And of course today we're now talking about mobile 3D scanning and what that means. And it's our belief at Knockout Concepts that mobile 3D scanning is going to fundamentally change all of our lives, and you're going to see soon why we think that. So early types of 3D scanning, point scanning, stripe scanning, and area scanning. And we'll go on through here literally real quick. Point scanning is exactly that, moving a stylus point by point over the surface of an object and capturing the dimensions There's stripe scanning, where you're literally moving a single laser over the surface and doing basically the same thing, usually a fixed position. Area scanning, this is anyone who's familiar with automotive industry. This is very common. I think GM or Ford has an entire building that's effectively one giant 3D scanner. And they bring cars, competitive cars, competition cars in there, and they scan the entire, because otherwise, I don't think BMW is ready to give them their full specs on any of their cars anytime soon. So this is a way for them to capture the exact dimensions and information on the design of the particular automobile, and then figure out how their products compare. And this is, of course, putting in a larger field of light onto the object, and then being able to capture larger swaths in a faster time. Now, there's another type of 3D capture called photogrammetry. This is a technology that involves using straight DSLR photo cameras, 2D cameras, and then capturing a bunch of images at the same time. And in this case, they have, I think, plus 45 cameras there. And then in taking those digital pictures and then stitching them together into a 3D model. This is an excellent way of doing 3D capture. It has some limitations, one of those being you obviously need light. Photos turn out pretty poorly when it's pitch black. Here is an awesome picture. So President Obama was the first sitting president to have his bust created from a 3D scan. So this was done by the Smithsonian, and I think they pretty much threw every single 3D scanning technology in the world at him because they had a window of like 10 minutes for him to sit and do this, and they couldn't get it wrong. So you see in this brief picture, you see the some photogrammetry going on. I think in the back somebody has a handheld device that's actually corded to a laptop, and some other technologies. So they managed to get a wonderful scan of the president. You see this technology a lot also in games, video games, and all these video games technology you see today, and you can see an example of the realistic, photorealistic qualities you see in today's video games. A lot of that comes from 3D capture of actual actors and actresses who are, and you see the detail of the clothing and all of the things that are able to be achieved with this type of technology. Here's another example of capturing an automobile, and sometimes for highly reflective surfaces, you would need to put a coating on it, depending on what type of technology it is, and that's why you see all the white powder on the car there. This was done by actually Audi, and they 3D scanned. It was for an installation in Toronto, right out in the street. And so they basically 3D scanned a bunch of Audi automobiles, created the older slot cars out of them. That's 3D printed there on the top left, you can see. So they 3D printed these scans, these models, and that's what's awesome about capturing something in 3D scanning. Regardless of the size, you can size the file into any size you want. And in this case, they made little miniature 3D printed automobiles, and they have a little camera in the dash there at the bottom right. And so then they put the slot car in a display on the street in Toronto, and people could walk up to it and actually race around the track and actually get a point of view from inside the slot car. So it was a pretty neat little promotional thing that Audi did. So then you see other applications of the technology, industrial applications, of course, which would be, in this example, doing maintenance on an underground pipe or in a facility, and you see a lot of applications for this. Places where in BIM or in building information management, or in places where you don't have a recent blueprint of the environment, and maybe some equipment was put in and the last blueprints were from when the site was created. Somebody can go in and then scan the area and immediately have the latest layout and know the dimensionalities. You can imagine an example of someone on an oil rig deep in the ocean, and someone else back at the headquarters needing to know about some equipment being put in there and not knowing what is the current layout of the facility. And short of flying out there, having a 3D scanner on site to be able to capture that is really important. Here is this, you have industrial 3D scanning, and companies like Faro and Leica have these massive industrial, very expensive 3D scanners that are on tripods. This was in London, in one of the tunnels in the tube, where you see the little black circles is where the tripod and professional 3D scanner was set. And so you're creating millions and millions of points here where you're capturing all this, the entire interior of the tunnel. So again, this is for architectural historical preservation. You'll see there's a great foundation that's going around trying to scan all the World Heritage sites. And this already came into important relevance recently when in Rwanda I believe there was a giant thatched hut, which was largest one in the world, and it had been around for decades and maybe even 100 years. And they had scanned it already and scanned the entire interior. It was used as a meeting space, and it was this massive structure. And then during the war, it got destroyed. So, after everything passed and stability was restored, the government came and sought out those scans, and they had them on file, and be able to then reconstruct the exact dimensions of this, historical building that was gone. And they were able to exactly reproduce it because they had the 3D scan of it. And of course, you see in applications in archaeology, when you see multiple types of technology, and 3D scanning is a technology that's use dependent, and there's different types of 3D scanning, and it, as if any tool, and we at Knockout definitely consider 3D scanning to be a tool, and 3D scanners are a tool. And so, of course, like any job you're gonna do, you take the right tool for the right job. And so you have multiple tools here where you have an area scanner over there on the right, and then a point scanner, contact scanner there. You see the guy using on the I think it's a whale skeleton there. But so yeah, and the point of all of it is to create a digital file, and then when you have examples like universities and museums doing this and digitizing their content, what you've now done is you've democratized the access to information in a way that I, as a researcher or a scholar in another country, don't have to travel to the Smithsonian if I can go and access the Smithsonian's objects digitally online and actually have the 3D model of that object, and I can do my research and understand what I need to do. So it's really amazing. And again, here's another example of more 3D scans and then being utilized in a gaming situation. So of course, when we talk about mobile 3D scanning, which is what Knockout kind of focuses on and what we want to talk about today, of course, you're trying to use laser light to measure the distance between the scanner and the object. In our device, we use infrared. This was a scene from a recent Disney movie called Big Hero 6. I don't know if any of you saw it, but your children. And the main character used a 3D scanner to create custom fit armor for his robot buddy there. And so that's an act of him scanning. So, and when we get into that, you'll see shortly how many applications you have with 3D scanning. That was just an Industrial Light Magic robot from Star Wars. This is a little bit about how we began with our first prototype. That originally, there's my partner Brooks and Myers, and that we 3D printed the entire housing and basically put together. We basically had to build a tablet from scratch because back when we started, the current off-the-shelf available hardware tablets didn't have enough processing power. The graphics processors weren't strong enough. So essentially we had to build our own, and then we 3D printed the housing. But what's happened, and we like to say before that we basically made jet fuel, but the hardware guys were still building biplanes. And now finally they're starting to build jets, and it's really exciting because there's a lot of off-the-shelf technology that is really powerful. And in fact, the next generation of cell phones and laptops are just incredible in how much more graphics processing and processing speeds and power there are. So there was another example of the backside of that device. We were at a fair at the Maker Faire in Detroit. And then we were there's a next generation with a different sensor on the back. And we in New York, there's a little kind of blowout of how we put together, obviously, the battery, the processors, and the sensor. So this is some evolutions of some of our devices from the far left. And we made that third one was a wooden casing that we did for a Maker Faire event where these makers get together and they're building and they're creating special unique projects, and so we attended this event, and as a tribute, we built a custom housing out of wood and laser etched it. And we did that at the Columbus Idea Foundry, which is another awesome, wonderful place that everyone should go and check out in Franklinton, which is allowing everybody to really innovate and create new ideas and things. There's our case. This is a fun little graphic. I think it's a Mario. So the second part of the hardware is, of course, the software, and that's what we are at our heart, is a software company. We do custom software, proprietary algorithms, and we have a cloud management side. So you can see here, this was at the Olentangy Caverns, which we've scanned numerous times, actually. And see, there's our lead software engineer, Steve Paddock, and he's doing a scan there, and you can see on the right some of that scan that was developed from that. And here's Andrew Slatton. He's our lead algorithm engineer. He's a PhD from The Ohio State University. And this is, I think it was the Indian power plant or water treatment facility down south of town. And we were looking at, this is again an example of what I said before about being able to capture the area of buildings and facilities to understand the current layout. There's my partner, Brooks. And in addition to obvious industrial or business applications, there's, of course, a massive creative application to this technology. And this was at CCAD. Brooks' background is in industrial design and a CCAD. He attended CCAD for industrial design. And so we've had artists and people interested in using our technology for all sorts of artistic purposes. And you can see a little bit of that there. Another example, another application, for example, scanning a dent in a car. So currently, a lot of the claims adjusters in the insurance industry are taking 2D photos, but of course, with the 3D scan, you have far more information. And again, information being the coin of the realm in insurance industry. I think this is a really awesome application of this technology as well. So we'll show you a little bit about how our device works and our software. And so this is a ski boot, Burton ski boot, and we love to scan it. And so you see on the right, the scanning button. Now you have a volume in which you can create a scan, and you can size the volume to any size up to a 20-meter cube. I think this is at the half-meter cube volume size. And so you just size your volume, start scanning, and you can walk around, and you see the gray was the live point cloud, and then with the, or without the texture on it, the scanning without the texture on it. And of course, with the color on it, you can see it there as well. And so after the time it takes to scan that, I think it's only a few seconds there, and the scan is complete. Right there, it's done. And so there, in that much time, I think it was 6 or 8 seconds there, and you've got a 3D model of this boot. You can then take that model, we can save it, we can save in multiple file types, and then we can export the scan, export the model right from the device if the device is connected to Wi-Fi, or you could mount it to a computer and just pull the scan right off of it from there. You can bring the scan, see you have multiple file types, STL, PLY, these are common. STL is a common file type for 3D printers. So scanning to printing, we always say, scanning 3D printers and 3D scanners are kind of a peanut butter and jelly combination there where it's great to have a 3D printer and it's great to have something to print. And scanning is one of the great ways that you can acquire three-dimensional objects to print. And of course, we also have a measurement, because the scanner captures at a 1-to-1 ratio. So you can capture in the bottom left there, you see our ruler feature and measurement tool, and we can capture exact measurements. So this goes on to when we talk about customization. And this is, and there's another application there, scanning instantly the dimensions of objects as soon as you point the scanner at them and capture a scan. So when we talk about why this technology and how is it going to be transformative, you're talking about once this technology it becomes more ubiquitous, and it's already happening both from our devices like ours and what's eventually going to come to mobile phones, for example. And eventually this technology will be on mobile phones. In fact, Lenovo just announced a device over the weekend that was going to have a depth sensor on the back of it. And it's really incredible what's going to happen. So when you talk about why is this impactful, what's going to happen, we talk about an age of mass customization, that we're on the precipice of this new era of mass customization. So why, scan your foot, send it to Nike. Nike makes you a shoe that fits you and only you. Custom fit clothing. Down the road, there's going to be generations that never going to understand why people bought anything that wasn't built specifically for them. It's just going to seem absurd. But you have and as the process of this kind of customized, now there's a whole lot of infrastructure that needs to be brought into place, and for sure 3D printing has its great advantages and it also has its disadvantages with regard to mass manufacturing currently. But I can tell you that we know that there's a lot of big business organizations that are moving to change that. And recently, for example, Hewlett-Packard announced their first 3D printer that you would thought a long time ago they would have been doing this, but part of their push is to create, in their new device, one of the features they extol about it is that it's able to do, instead of 3D printing for rapid prototyping, it's actually doing 3D printing for manufacturing, or 3D printing for a final product, a actually ready-to-use product. So those kind of technologies are all at an infancy right now, but they're growing rapidly. And as that comes into line, you're going to be able to bring on this. It's going to enable this environment in this new era of mass customization. So get what you want in the shape that you want or fit specifically to you. Here's another architectural use. I think that was on at OSU campus. And you can imagine also we talk about creative uses for game development as a device for 3D asset capture of assets for video games. So instead of going out and going and modeling a doorway or a post from scratch, I can go take a real object from my neighborhood and bring that into my video game if I'm a video game developer. It opens up a lot of things. This is what you see when you so. With 3D scanning, you still at this currently have to use the old technique of photography where you have to be perfectly still to take the photo. And the same with 3D scanning. And you see here what happens with motion, and you get this frame by frame movement there. But actually, we've had people interested in talking to us about the applications for that with physical therapy, of knowing exact degrees of movement. So even in, there's all kinds of applications in that way as well. This is a friend of ours, Adam, who owns the Land Grant Brewery here in Franklinton. And this is actually a fun scan because we actually scanned Adam in that pose so that we turned him into we 3D printed him and turned him into a tap handle at his brewery. Now, it was a pretty cool way, and that's, again, one of the innovative things you can do with 3D scanning is not just direct one-to-one, but do, the customization of what this technology allows. It allows fun projects like that. Unfortunately, Adam, somebody got a little too excited and snapped him off at the knees there, or at the ankles there, but we're gonna potentially do it again and cast him and get him a solid metal. But it was a fun project. So yeah, you can see some other things that we've done. There in the left, Red Bull Rally Car team here in Columbus, out of Dublin, were interested in a fin that they had part of, and they wanted to scan the broken part that they had, and then they digitally replicated the other side of it, and then they were able to utilize it on their car. Then in the middle, you see the scanning of the Olentangy Caverns. And that's a partner of ours, and he's actually putting the caverns into a VR application so that you could walk around inside of one of the Oculus VR headsets and actually walk around or look around the cavern and feel like get a 360 view of the caverns from his application. And then, of course, my medical background, there's a lot of medical applications for this technology as well. One of our customers and one of our clients that we work with closely is involved in prosthetics. So a lot of the vets come back and they have these prosthesis needs, which has really grown. And the process of getting a custom fit prosthesis has been very laborious in the past. And now with the scanning technology, they're able to scan the stump and the amputation point and actually get a perfect dimensionality to that so that they're able to reduce the fit time, and instead of having a person coming over and over again for multiple fittings, and really get a solid, good fit that ultimately has the medical advantage of reducing patient return for issues regarding fit and skin disturbances because of that. And then there's a ton of other medical applications that coming down both in reconstructive surgeries or other areas where you could see having this 3D model of the device and custom fit. We have people interested in our technology who are involved in for CPAP masks and custom fitting anywhere where a custom fit of a scan would help with the custom fit in the medical side. There's a ton of uses there. And then just going through, so this is kind of a fun slide because, see, down there in the middle is Todd Slaughter. He's a renowned sculpture professor here at The Ohio State University. And Todd came and wanted to do some poses with us to get scanned to work on some projects that he had for ideas, and we were happy to do so. But if you see on the left there, you see that tunnel, which is an interesting environment, and you could imagine like a little Mario Kart or something running through the tunnel there. Well, that isn't actually a tunnel. That's the inside of Todd's leg. So there's another aspect to all this technology where the scans themselves are fascinating, and if you delve and zoom in on them, you could, again, with video gaming applications, you could create whole worlds there just in weird little scans like that. So very fun technology. And here we're at the very end. I wanted to kind of speed through this to kind of talk more about why and open up the questions about the technology. And I would like to do a quick demo. Maybe I'll scan Trent real quick for you with one of our scanners. But the thing about this technology, as it's coming out to the market and to the cell phones and to the society as a whole, people are like, well, what am I going to do with 3D scanning? Why is it important to me? Back when the camera was first put into the cell phone, I think it was 2002 was the first mass-produced camera or cell phone with a camera. At that time, no one could think or imagine that, okay, well, I mean, at the time, people were kind of like, well, this takes not a very great photo, and I've already got a digital device that takes a great photo, and I've got a phone that works fine. Why do I need those two to be married? At that time, people had a hard time. No one really imagined something like Instagram, a multi-billion-dollar company whose entire existence is predicated on a cell phone having a camera inside of it. Or another example would be, you can even argue Facebook, whose existence is sharing in social media and this whole aspect of sharing digital images and the multi-billion-dollar industry that has come up around that. In 2002, nobody could even see that. And that's often what happens is where you say, okay, well, why should I care about 3D scanning in a cell phone? Well, because the problem is that we often look through at the future through the lens of the present. And that's definitely not what we need to do, because it's going to be a very, very fascinating and exciting future. And when you have this technology in people's hands, all kinds of things open up. So I guess basically for that, I'd like to open it up to questions. Sure. Thank you. Yes, go ahead.
Boot rendering. How big of a file is that?
That one is probably around 6 to 8 MB. A bust scan maybe would be of a person, which we've taken a lot of, be anywhere from 12 to 18 MB. So they're pretty, of course, it's not about the size of the volume in which you're scanning, but of course what is inside the volume and how many features it has and what the intricacy of the object is. But, you can, there's, of course, once you take this into and you can take any of those files and take them into a any sort of CAD software, be it Revit or any of the Adobe software that you want to use. Oh, absolutely. Go ahead.
So what kind of precision and accuracy do you get out of this?
Excellent question. This goes back to what I was saying about the right tool for the right job. We have our accuracy is sub-centimeter accuracy. If you needed millimeter or sub-millimeter accuracy, you would use a different technology. The advantages that we bring to the table with our technology is a fully mobile device. And also some of the larger, more accurate devices start at, even the ones that are, quote, handheld, but they're actually corded to a laptop. That's minimally priced at about $13,000 to $15,000. And then the big tripod scanners can be $50,000, $60,000, $100,000. So what we have is a sub $5,000 device, and actually it's $2,500 is what we sell our kits for. But we offer, so exactly, it really depends on the object and what you're trying to do and what tool is best for it.
What publicly traded companies are in this space?
Publicly, you would talk about the big, like I mentioned, Faro, and the big guys. With mobile scanning, we have a few we have one or two competitors who are small startups like us. They're not in, the larger guys are focused on their industrial applications. So 3D Systems or a Stratasys, they're both involved in heavily. Stratasys is, of course, originated 3D printing. And so they are, both 3D Systems and Stratasys are big 3D printing companies. But they've also have scanning aspects because of that natural connection. Yeah, sure.
But I mean, is there a substantial difference between the printing and the scanning companies?
Well, less. It depends. I mean, yeah. There's a lot of the 3D printing companies have scanning aspects to them, but then a lot of the more industrial 3D scanning, the equivalent to a Faro or a Stratasys would be, a 3D Systems or Stratasys would be somebody like Faro or Leica, and of course they're more image focused, and that's what their bailiwick and what they focus on. But yeah, I mean, the 3D printing companies are starting to see the value in bringing some 3D scanning in house.
So right now, I hear you talking about the accuracy being in size, and obviously as technology progresses, they'll get smaller.
Yes.
What type of research is being done, or is there really any existence for, I think about the medical field and maybe being able to do a less invasive surgery?
Oh yeah, absolutely. So, I mean, you've seen GE has, I think, various times demoed, and they have devices out in public where they do handheld ultrasounds and that sort of penetrative technology. Currently, I'm not sure exactly where those devices are at, and I'm sure there's stuff moving forward with that. I mean, there are people that are taking CT scans and PET scans and doing the 3D models out of that, full 3D models, not just slices. But yeah, that's coming as well. I mean, you're going to be able to really both do external and internal and scans, and as you said, it's going to be really amazing when a doctor could actually look inside of somebody before they open them up. So yeah.
When they did the bust of Obama, they scanned him, and then when they printed it out, what was it made of?
Okay, so with 3D printing is a fascinating technology, and its technical name is additive manufacturing, because unlike subtractive manufacturing, where you have a piece of wood and you take away the wood and you end up with a stool, with 3D printing, you only use exactly the amount of material that you need to make the object and nothing more. And if you've never seen a 3D printer, or you're not familiar, I don't know how many of you are, but it's very much like a hot glue gun in the kind of lower end consumer 3D printers, where they're pushing out and extruding a 3D plastic filament, and it can be ABS or PLA filament, and then onto a heated surface, and then that surface can move in the X, Y, and Z axis, and that's how you create the 3D model. But that's just one type of 3D printing. The current Joint Strike Fighter has over 240 parts, I believe, that are 3D printed. So on SpaceX, Elon Musk's company, he's got videos online of parts that they use on their rockets that were 3D printed. And they use metal, and they do metal powder, titanium powder, and they do a form of laser sintering to create the 3D, basically the same 3D additive manufacturing process, but with metal. And speaking to that kind of material-wise, there's also the whole aspect of biological materials that they're starting to use to 3D print with stem cells. And so then being able to actually 3D print out organs. And in fact, they've already actually 3D printed an entire kidney. But it's not functional yet, but they've got the right tissues in the right order, which in of itself is incredible. And so that is pretty crazy what's coming on. And so this entire scanning and 3D printing future is really going to open up a lot of opportunities for everyone.
Do you see that they're going to link this technology to drones or anything where you can go overhead and print cities, where if you're going to go to a city, maybe everything's done? Or
Absolutely. Yeah. That's a lot of where that photogrammetry technology comes in, and there are people already using drones to scan, take three-dimensional images of buildings, of entire blocks of cities. So yeah, when you start looking at combining this technology with the drone technology and with the VR, the virtual technology, for example, being able to collaborate in teams from around the world, put on a virtual reality headset, and then come into a virtual space and see an actual object there, and be able, the whole team from wherever they are in the world, all be able in that space and move that object around. These are the kind of transformative things you're going to see with all of this digitization and virtualization of objects. Okay, yeah. Thank you.
Thank you very much for your attendance today. Be a Rotarian all week long.